Yeah, so like we're doing JavaScript neural nets. I'm not entirely sure why we're doing this, but anyway, like we made this app, and I'll just like explain it real fast. Right, so like if you're just looking here, this is what dimension was this? This was like I'm gonna say 16. Well, so it's dimension 4. So it's like 4-dimensional binary strings, and we're visualizing the pairwise distance matrix, right? So this is saying like the string, which is all zeros, it has like Hamming distance of 0 with itself, and then like I'm arranging the strings by Hamming weight. So these are all the strings that have a single 1. These are all the strings with a 2. So anyway, you get up to here where it's like the negation. This is the all 1s. So so like bright yellow corresponds to like maximum Hamming distance, and then like black corresponds to 0 Hamming distance or identity. And then what we do is we take all of these 16 strings and we run them through a neural net layer where we have 4 units in the layer so that we're retaining the dimensionality. And every unit in the layer is computing thresholded Hamming distance. So like every unit in the layer has a parameter vector, and then it takes the input and it computes the Hamming distance between the parameter vector and the input, and then it's like 1, output to 1 if the Hamming distance is like greater than half. Otherwise it's 0. And those parameter vectors like are randomized. And so it's kind of hard. Like I was hoping you could easily like looking at the pairwise distances, I was hoping you could like what's happening would possibly be more interpretable. It's not entirely clear that's happening. Like one thing you can, if you're looking at this, it's like these 2 rows are identical, which possibly implies that they that the representations are identical, right? So like this input, the second row input is being mapped, to some 0, 1 vector, but the third input is also being mapped to. Actually, yeah. We can prove that because because like 1 row 1 versus 3 is black, so they have 0 Hamming distance between them, so they're the same input. Yeah, and like once you have 0 Hamming distance in that way, the 2 rows are gonna have the same distances to every other point. Yeah, and like we had some other kind of like visualizations, like this red is up here, except it's saying that this distance is like greater than it was Right. So anyway, yeah, that's what's going on here. And then we end up here, and, that basically means we end up with 2 points. That's, yeah, you just have 2 points, and, so like these 2 inputs, so like out of the 16 inputs, 2 of them are mapped to this 1 point, and then the other 14 are mapped to a different point. And we know that the distance between those 2 points is 2? Whatever distance corresponds to this shade of yellow. Could be 1. I mean, it looks like it's 1. No, because this is 1. So I'm thinking it's 2. Might be 3, Right, so like that's what this like neural net is doing. And so what we want to do is like we want to program our. First of all, we want to ignore these 2 rows. Then we want to program our own neural net that will achieve this, output. So like in other words, so it's saying like we don't know what the 2. All we're saying is like the 2 yellow rows, the inputs corresponding to them are mapped to 1 point. And, and then the other points are mapped to a different point. And, so we'll try to we'll just go through that, because I have implemented all of the, user interface using AI, right? Yeah, because like JavaScript programming is hard. Okay, so yeah, let's check this out, right? So like we're starting here. This is like a whole new, right? This is like the top neural net. This is the bottom neural net, and we're trying to hand program this neural net. So we want this, which is the starting pairwise distances. We want them to look like this. And what we do is we focus on this, and what this little thing is saying is, so like we've randomly generated a layer, right? Like we have, like when you press G, like it generates a random layer. And what it's saying is like if you have like a red here, it's saying, for instance, that this layer, that's, yeah, I should go down to a lower dimension or something. I'm trying to, anyway, red means it's unimproving the pair with respect to, this is the target output. Right, so like in this target output, this whole square is black. So this, right, our layer makes, say this entry go from dark yellow to brighter yellow. So that's moving those 2 things farther apart. And we want them to be black, so we want them to be closer. So it shows up as red. So red means unimprovement. in either direction with respect to like the immediately previous layer and the target output. And then like the green is like fatal, because the green means that the layer is mapping these 2 points, the row and the column point, to the exact same point, but that point has to be separated by the target function. So like, we take this as a target function, like this is yellow, whereas in this layer, I don't know what the exact one was, but like there's a black there. Yeah, so anywhere you have like a black entry where it's like not black in the target function, then that's not recoverable. So like basically you have to avoid, like, yeah. And yeah, so that's like the whole programming heuristic. Like we just, we click G, like the key, which is just short for generate. This is all AI stuff. I didn't come up with that, but you click G, and then it yeah. So like in this case, in this layer, this was looking good, right? Because we don't have any greens. Also, I forget what this row is. Okay, yeah, this row is just raw distance to the target. Yeah, I mean, you could look at any of the rows, but anyway, yeah, like this looks good, right? Because like we have a lot of blues, right? Blue is good. It means it's moving points farther apart that are supposed to be further apart, or it's moving points closer together that are supposed to be closer together. So we shall accept this layer, and then yeah, now the visualization is kind of terrible because I need a way of like making the target, like bringing it down or something. We're just going to ignore that. Like we're just going to remember, it's like, it's like a pound sign. Or like a hashtag, Okay, so this is the whole programming. This is the whole method, and like you just click G until you get one without any greens, right? And yeah, this doesn't clearly have any value at this point. But it is kind of like a fun game though, right? So, yeah, so I think I'll try to program some neural nets, and there's maybe like a few implementation features I was going to see if I could get AI to implement for me. Like one thing in particular is like automatic filtering of like green. Anyway, okay, so like we'll just keep on this one, right? So we're trying to achieve this, and I want it to look like this, right? And yeah. So yeah, we're just using this heuristic of like whoops. Oh, I should have accepted that layer. Oh, I blew it. Yeah, we're just using the heuristic of like no greens and like preferably if you could have more blues. But I think it's also possibly the case that now that's a lot of blues. It's also possibly the case that, or I think it's definitely the case that, like, yeah, like most neural nets, like on an individual input, like sometimes the representation gets worse for a while. I mean, like, like, is any of this relevant to like 100 billion parameter language models? Don't know. You never know. Anyway, okay, so we're going to accept this input because it has a lot of blue and no green. Okay. And then we're just going to keep trucking. Right. Sure, that looks good. Yeah, see, that's a lot of red. I don't know. Should I... That's too much red. I should have accepted that. Okay. Accept. With an A, you know, like accept. Okay. That looks good. We'll just go ahead and accept this one. I mean, like, we've already used more layers than the, you know, than like the actual implementation. Which, by the way, this is just a random neural net. I mean, it's not. We're basically trying to mimic, like a randomly generated neural net, taking the final layer as the target. Yeah, we're not doing very well. Like, we're supposed to be here, and we're down here. Yeah, it's not going very well. I mean, yeah, I was hoping this would give me some sort of insight into, you know, like neural net interpretability, at least for like small binary MLPs. But I guess if we've learned anything, it's not, you know, very small MLPs are like arbitrarily complex. Right? I mean, this is like literally 4 inputs. Everything is binary. Anyway. Anyway, I'm going to accept this layer. Also, my throat just gave out on me though. We're going to accept. Yeah, cool. Yeah, my throat's back. Everything is cool. Accept. I think we're making progress now. I think we're making a lot of progress right now. Come on. We're almost there. Yeah, okay, accept. Okay, so yeah. I think we're basically there, right? Other than the, okay. Alright, so we got there. Well, I think mostly, like, it's, right, like, the exact distances are slightly, yeah. Anyway, right, so, what did we learn? Um, yeah. Um, I think maybe this color mapping is garbage. That's possibly one thing that I learned. Um, I don't know. Yeah. Um, it's really not clear what we learned. Um, we'll just do a different one. You know, that's cool. Everything's cool. Um, no, I don't like that one. That one's what's going on here? Well, this is saying like we have like 3 points. We're mapping everything down to 3 points, and yeah, like 2 of the inputs are in one group. Another 2 of the inputs are in this other group, and then all of the other inputs are in a different group. Yeah. All right. Yeah, we'll just try to implement that. Yeah, okay, so, okay, this doesn't have any green, which is kind of weird. It's kind of weird that, like, the first thing you hit doesn't have any green. Yeah, we had just got lucky, because a lot of them have green. Oh, look at that one. That one's a good one. I think that's kind of the thing. Yeah, I should probably go to like a lower dimension. And, because then you can possibly try to interpret stuff. Well, so we'll just try to, yeah, but we'll try to do this one. Right. Yeah, we'll just try to do this one. Okay, no green, except, no, that has a lot of red. I'll take it. I'll take it. Oh, that has too much red. Oh, that's way too much red. Like, what's happening here? Saying like this. Why is that? Like, what's going on with this point? I don't know. Sure. I'll take it. Who cares? Yeah, see, like, I was going to implement a button where it just searches through all of these automatically. Whoa, that is a lot of blue. I mean, you gotta accept that. That I don't know about. Oh, that's a lot of blue. That's a lot of blue. Yeah. Yeah, I'll just take that. Okay, so we've already blown our layer, you know, like, we're getting kind of close, though. I mean, is it? Oh, I see. Yeah. Okay. Like, this is basically it. This is it. Right? Well, okay, so like the difference between this and this, right? Yeah, you still have to differentiate these, like, this row, right? Right. Can I accept that one? Hopefully. Don't remember. Right. Yeah. Okay. I'm gonna go to a lower dimension. I'm gonna go to 3 dimensions. 'Cause I think I feel like you should be able to better, like, interpret what's happening. Yeah. Okay, 3 dimensions. Also, this is breaking my computer, so it's too heavy. Alright. I guess that's the thing. Right. Okay. I mean, it's kind of, yeah, you should just be able to interpret, like, what is this neural net even doing? Like independently of programming it. Right? Like, you should be able to... try to understand what this neural net is doing. Like, you know, so we're in 3 dimensions, so we have 8 inputs. 8 points. And, so the first layer here, like, what is it doing? I mean, it's maintaining 8 points, so it's just it's doing a permutation. And it's doing a permutation. Right? Is this one also a permutation? I think these are all... yeah, like, this is maintaining 8 points also. So I think this is a permutation. This is a permutation. Like, this is also a permutation? I mean, at the end, we only have 4 points. So, like, this layer is collapsing some points. Also, I think you can do this with, like, a single layer. Yeah. Is that, that must be, is that a bug in my code? Like, so it just automatically gives me the correct layer? Yeah, so, I mean, I guess that's some of the problem. We're trying to give, like, English descriptions to, like, the, geographical, or the geometrical, movements that single layers are doing. And, it's too hard. I mean, yeah, like, um, yeah. Wow, this one's hard. The heck? Oh, right. Um, so, like, yeah, why is this blue when there's no change? Yeah, I probably have, like, a color mapping issue. Alright, we'll just do, like, a 5-dimensional one, and then I will quit. Alright. That's a toughie. But see, it's possible in 3 layers. Also, that looks cool. Like, what's going on here? Is this a permutation? Don't know. Kind of looks like it, but yeah. All right. So anyway, we'll just try to do this one. Ooh, my layer spacing is annoying. Okay, are we gonna get like the first layer we get without any green? I'm taking it. Might be here a while. Yeah, I might have to automate this part. No greens. Except, alright, So what did that do for us? Okay, so, right. See, like we're trying to get here, and we're like here. So it's not the one that the, you know, like this is different, but, actually it's kind of similar, I don't know. Anyway, we'll just get back to looking for a layer here, without a green. Okay, I'll take it. I will take it. Yeah. Yeah. Also, I think on some level, like, you're just trying to match the diagonal block structure or something. I don't really know. Yeah. Oh, should I take that one? Nah. Ooh, that's got a lot of blues. I'll take it. Next. Oh, dang, that is a ton of blue. Except, that's not looking bad. That's not looking bad. I think you have to accept, like, if this is correct, it's saying everything is correct except for these two rows. And yeah, so we just need to correct those two rows. Okay, that slightly corrects them. I will accept. And, okay, accept. This is just gonna have like 6 layers to correct these two rows. And that's cool. What? No. It's like, it's really going slow. Oh, is that it? We did it. We did it. High five. See? Trying to get that. Boom. Look at that. Now this neural net did it like in, you know, like 1, 2, 3, 4 layers. And we did it in, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9. Although I think, like, I mean, like, morally we did it here. So we just had these weird 2 rows. Like, what was going on with those 2 rows? I don't know. Yeah. So that's cool. Alright, I'll do one more. I mean, like, it is fun to do. Even though, okay, this one's too hard. So we're gonna re-roll. Oh, that's nice. That's a cool one. Look at that. Yeah. Also, yeah, alright, we'll just try that one. Alright, we need it without greens. Whoa. Whoa! That is super cool. I don't know what's happening there. That is very cool. also cool. Okay, so that's gonna take a while, I guess, to find one without a green. I wonder if there's a way you could, like, influence, like if you could hill climb or something on the layer to avoid green. This might take a while. Yeah, okay, this might take too long. Okay, you know what, this is a case for AI. So, I'm going to have it, yeah, I guess that's the last thing I'll do. I'll just see if AI, we need a button that, you know, just generates these layers, right? Like it's just selecting random parameters. But like we need a button that scans until it finds a layer that doesn't have a green. It kind of seems like, I mean, like if you, because, you know, it's looking like a layer without a green here seems so rare that, I don't know, it seems like as soon as you find one, you're kind of like, the rest of it is easy, maybe? Alright, I'm gonna try to do the, I'm gonna do that. I'm gonna try to implement that, which is the button. Let's see, can I implement it myself though? Like that would probably be easier. I don't know where the, okay. Generate layer. You see, update visualization. Okay, now I'll just use AI. Okay, so I'm just gonna copy all of this. We're gonna use Claude, and we're going to say, we would like to add a feature where the user presses, you know, a key. I'll say J. It's kind of like G. Has anybody ever thought of that? Like G and J are kind of similar. Yeah. Our user presses a J, and okay, so I need to yeah, but how do I define like fatal though? That's the problem. Yeah. Okay. Right. Okay. And the app like repeatedly and the app acts like it is repeatedly pressing G to generate a minus a new random layer. Unbound stops when it has found a layer without it's found a layer holds common metrics, does not have value 1000. Does not have any entry with value 1000, like I'm using 1000 for the green. Right. Okay. Bombs away. Update the event list. Yeah. Okay. So. Ooh. That doesn't look good. Attempt. Okay, previous code remains the same. Attempt generation. Right. Activations. Right. Okay, so it gave me a function which looks weird, and we modified the add event listener thingy. Where even is that? It's right here. Okay, cool. Cool, very cool. This is gonna break everything. So that's cool. And okay. Generate until valid. Why does the indentation not copy it correctly? You know what I'm saying? I can't even tell if it's right or not. No, this needs to be over one, I think. Okay. Alright, so what it's saying is it's just using the old GAB. It didn't close this parenthesis, which seems bad. Okay, generate until valid. And let's see. You know, we don't want to break, like we still want to visualize it. Yeah. Generate until valid. J. Generate until valid. Attempt generation. Why didn't it make that its own function? Is this good? Right, but we actually actually want it to display the thing. So, yeah, visualize network. Or like update visualization. We still wanna. Well, I don't know, let's try it this way maybe. Assuming this works. Okay. Yeah, I mean, that doesn't work. Good Lord, what is all that? That's crazy. I should. Oh, I pressed the wrong button, actually. You're supposed to press J. Okay. Dang it. Okay, yeah. So, okay. Press the wrong button. Alright. Oh, nice. Nice. Okay, I guess that works. Okay, let's try higher dimension. Also, let me kill those console thingies. Yeah, probably don't need that. Probably don't need that. Sure. Okay, so we'll go up to higher dimension again. By which I mean 4. Okay. Yeah. Wow. Okay, so that seems to work. Right. 3 attempts. Okay. Whoops. Okay. Press A. And then like G. Okay. Okay. Accept. Alright, so now we'll press J. 4 attempts. Very cool. Very cool. Yeah. I mean, I wanted it to animate the search, but that's fine. Okay. Let's go down here and yeah, that's looking good. Sure. Looks good. Accept. Gee. Are we matching this thing yet? No. What's the target? Right. Okay. Yeah, we'll say that's close. Alright, let's go to higher dimension and see what happens here. That looks terrible. 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 The hell? Yeah, that looks terrible. That looks terrible. Sure, that looks cool. That's cool. Alright, let's get into it. Okay, so green, 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 green. Okay, I'm gonna press J. Ooh. Oh my word. That's amazing. Alright. Alright. That's very cool. Alright. Next layer. Still got a lot of greens. Yeah. Alright. I'm gonna press. Oops. I don't think that one's good. It has too many reds. We'll just keep going here. I'm gonna press J. J. I mean, that has a lot of reds, isn't it? And then. Also, how many attempts did it take? Whoa. 126 attempts. Yeah. That's crazy. What's happening? Sure, we'll take that. Okay. I don't know. I'll take it. Who cares? Okay, J time. Guess that doesn't mean drugs. Alright. Sure, I'll take it. This isn't going very well. Okay, press J. Is it doing it? I can't tell. I don't know what it's doing. I'll press it again. There you go. Accept. J. Yeah, that's fine. G. That's fine. G. What's the thing we're trying to do? I mean, we're way past. Oh. Yeah. Yeah, we're not doing very well. That's fine. That's fine. I don't like that one. Ooh, that's good. That's a good one. Okay. Don't like it. Oh, that's good. That's good. Is that done yet? I mean... None of these are very good. What am I trying to do? I tried to do this. Like, so it's kind of like that sort of thing going on. Yeah, we kind of got that going on. Jeff. None of these are looking good. Whatever. I mean, they all seem to be equally good and bad. This is possibly like a thing. Oh, I'm looking at the wrong one. Okay. Yeah, I'm just gonna call it there. Oh, dang, man. I reject